Europa drifts in the cold shadow of Jupiter, a frozen world wrapped in silence and ice. At first glance it seems lifeless, a place that should have been still, inert, forgotten among the outer planets. Yet something in its fractured shell whispers of movement beneath the crust. Tides stirred by Jupiter's immense gravity may churn a hidden sea. An ocean vast enough to hold more water than all of Earth's combined here. In the darkness beneath miles of frozen stone, the story of another world may be unfolding. Into this mystery gazed humanity's newest eye, the James Webb Space Telescope. With its infrared vision, it turned toward Europa, hoping to peel back the frost and reveal what had long been hidden. What it found was not silence, it was chemistry in motion, signals of replenishment, hints that the surface is not closed but breathing, exchanging, alive in its own restless way. The question emerging is larger than science alone. If Europa is active, if its secret ocean connects with the surface, then it becomes not only a place of frozen beauty, but perhaps the most likely cradle beyond Earth where life might stir. The ice gleams in sunlight, reflecting the distant fire of the stars. But the true story waits in shadow, not on the frozen surface, not in the light, but in the vast black ocean below. An ocean that has never seen the sun, and yet may hold answers to the oldest question humanity has ever asked. If you are new here, join the journey, like, subscribe, and let's begin. In the year 1610, an Italian mathematician turned his crude telescope toward Jupiter. The glass tubes he carried were simple, yet within them lay the power to reshape humanity's view of the universe. His name was Galileo Galilei. Through imperfect lenses, shimmering with distortions, he saw 4 faint points circling the giant planet. Night after night, their dance repeated with clockwork precision. They were not stars as first believed, but moons, and one of them, destined to become central in humanity's search for life beyond Earth, was Europa. To Galileo, Europa was only a point of light, a small companion lost in the brightness of Jupiter. It had no surface, no details, no mystery. It was simply one of many, an unremarkable bead of light in the endless black. Yet its existence planted a seed. For the first time, the heavens were revealed as more than an immutable dome. Worlds orbited worlds, and the cosmos was no longer Earth-centered. Europa, faint and cold, became part of this revolution in thought. For centuries after Galileo's discovery, Europa remained silent in the background of astronomical charts. To early astronomers, it was just a marble of ice, too far from the sun to offer warmth, too distant for serious study. The instruments of the time lacked the sharpness to see anything beyond a tiny pale disk. The moon slept in obscurity, waiting for technology and imagination to awaken its deeper truth. It was not until the 20th century, when spacecraft were hurled across the void, that Europa revealed its face. The Voyager missions in the late 1970s passed Jupiter and for the first time sent back images of Europa's frozen skin. These photographs startled scientists. Instead of the cratered, lifeless body they expected, Europa appeared remarkably smooth. Its surface was a canvas of fractured lines, great ridges stretching for thousands of kilometers, crossing and recrossing like scars etched into ice. The world looked shattered, as if its crust had been broken and rearranged. Among these scars lay vast regions known as chaos terrain, puzzle-like fields where ice blocks the size of cities appeared broken, rotated and refrozen in place. The sight suggested a restless interior, as though something beneath the surface was pushing upward, disturbing the crust. Unlike most icy moons, Europa was not dead. It was moving, shifting, changing. Voyager's cameras had uncovered a paradox. A world that should have been frozen in silence was, instead, dynamic. A new suspicion arose. Perhaps beneath the rigid crust of Europa, hidden under kilometers of ice, there was water. An ocean kept liquid not by sunlight, but by gravity. Jupiter's immense pull stretches and squeezes Europa in a constant tidal rhythm. This invisible kneading generates heat inside the moon, just as bending a piece of metal makes it warm. That heat may be enough to prevent the ocean from freezing solid. If true, Europa would hold a vast, hidden sea, an ocean larger than all of Earth's oceans combined. The Galileo spacecraft, launched in 1989 and orbiting Jupiter in the 1990s, returned even more startling evidence. Its instruments measured Europa's magnetic field, hinting at a conductive layer beneath the surface, consistent with a salty ocean of liquid water. High-resolution images showed the crust crisscrossed by ridges and plains that looked geologically young, as if the surface was constantly renewed. Galileo even detected hints of unusual chemistry on the ice, salts and compounds that could be the fingerprints of a deeper ocean welling upward. These findings reshaped the scientific imagination. Europa was no longer seen as a frozen wasteland, but as one of the most promising places in the solar system to search for life. Beneath its icy crust might lie hydrothermal vents on the seafloor, similar to those on Earth, where life thrives in the darkness, nourished by minerals and chemical energy. The possibility was staggering: a second ocean world, alive in shadow, orbiting far beyond the warmth of the sun. Yet Europa remained elusive. Spacecraft could only skim the surface, catching fragments of data. The ice crust is estimated to be tens of kilometers thick, far beyond the reach of current probes. What lies beneath cannot be seen directly. The ocean whispers through magnetic fields, through the chemistry on the ice, through fractures on the surface, but it does not reveal itself fully. Scientists knew they were glimpsing only hints of the truth. For decades, telescopes on Earth and in orbit searched for more signs. The Hubble Space Telescope, with its ultraviolet vision, detected faint signatures of possible plumes, jets of water vapor erupting into space from Europa's surface. If confirmed, these geysers would provide a natural window into the hidden ocean, spraying its secrets into the void where instruments might one day catch them. But the plumes appeared faint, inconsistent, flickering in and out of detection. Europa continued to tease, never offering certainty. And then came the most powerful eye humanity has ever built: the James Webb Space Telescope. Launched in 2021, Webb was designed to read the cosmos not in visible light, but in infrared, sensitive to the heat signatures and chemical fingerprints written across space. Unlike Hubble, it could pierce through the cold darkness with extraordinary clarity. When Webb turned its gaze toward Europa, scientists hoped it could resolve the puzzle. What lies on its surface? And what does that surface reveal about the world below? Infrared spectroscopy became the tool of revelation. Every molecule absorbs and emits light at specific wavelengths, leaving behind a signature like a fingerprint. Webb could capture these subtle imprints across Europa's icy skin. The telescope did not merely photograph Europa, it read it, decoding the chemistry written into its crust. What Webb found was startling. Concentrated deposits of carbon dioxide were identified on the surface, clustered in a geologically young region known as Terra Regio. On Europa, radiation from Jupiter should quickly destroy such fragile molecules. Their presence suggested replenishment from below. The implication was profound. The ocean and the surface might be connected. Chemicals from the deep sea could be reaching the surface, frozen into place where Webb's instruments could read them. For the first time, the suspicion of a hidden ocean was given chemical weight. The surface was not sealed forever. It was porous, fractured, alive with exchange. Europa was no longer only a frozen marble. It was a breathing world, whispering its secrets into space. The history of Europa's exploration is the history of humanity's growing ability to see the unseen. Galileo's telescope revealed only a point of light. Voyager showed a cracked shell. Galileo the spacecraft hinted at a hidden ocean. Hubble glimpsed possible plumes. And now Webb, with its deep, patient vision, reads the molecular fingerprints etched into the ice. Each step pulls the curtain back further. Each discovery deepens the mystery. Europa is no longer just a moon orbiting Jupiter. It is a frontier, a mirror held up to humanity's most ancient question: are we alone? Somewhere beneath that fractured crust, in an ocean unseen for billions of years, the answer may lie waiting. And with Webb's eye upon it, the first chapter of that answer has begun to unfold. In the frozen reaches of the outer solar system, sunlight dwindles into weakness. By the time it reaches Jupiter, it is less than 4% of what warms Earth. Beyond this giant, the sun is no more than a pale star, faint and distant, unable to offer its life-giving fire. And circling in that realm of shadows is Europa, a moon that by all conventional reasoning should be a frozen, silent rock. Here, temperatures plunge to extremes that eclipse even the most merciless landscapes on Earth. Europa's surface remains locked at around -160 degrees Celsius. At such cold, steel becomes brittle, air liquefies, Water is not a fluid but a rigid mineral, harder than granite. In this environment, nothing familiar to terrestrial life should stir. All movement, all chemistry, all vitality should be extinguished beneath the ice. The paradox begins here. By all measures, Europa is a world beyond the habitable zone, that fragile band around a star where liquid water might endure at the surface. Earth resides within it, warmed by direct sunlight. Mars skirts its edge, its history marked by oceans that dried as the light thinned. But Europa exists far outside. Its surface should be locked in perpetual stasis, an eternal winter where sunlight dies long before it can nurture. And yet, Europa does not behave like a dead moon. Its skin is fractured, its surface young and restless. The smooth plains lack the cratering of ancient silence. Instead, they bear the marks of motion and renewal, as though the crust has shifted, cracked and healed over time. Regions of chaos terrain reveal shattered ice, reassembled like a mosaic across vast plains. These scars are not the product of asteroid bombardment, but of something moving within. Something that should not exist in such a frozen world. The question arises, where does the energy come from? If not from the distant sun, what force could possibly keep this moon awake against the freezing silence of space? The answer lies in Europa's intimate dance with Jupiter. Jupiter is not simply a planet, it is a giant, a mass of swirling hydrogen so vast that more than 1,000 Earths could fit within its volume. Its gravity dominates the solar system, a force so strong that it tugs at its moons with invisible chains. Europa is caught in this embrace, circling Jupiter every 3.5 days in a tight and relentless orbit. But the path is not a perfect circle, it is slightly elliptical, shaped by the gravitational influences of Europa's siblings, Io, Ganymede, and Callisto. This subtle elongation creates a cosmic rhythm. As Europa sweeps closer to Jupiter, the planet's immense gravity stretches the moon, pulling at its rocky core and icy shell. As it moves farther away, the grip relaxes, and Europa flexes back. The cycle repeats endlessly. Squeeze, release, squeeze again. This is tidal heating, the secret furnace of Europa. The effect is profound. Inside the moon, rock grinds against rock. Layers shift under pressure. Friction generates heat. The entire body of Europa pulses in response to Jupiter's gravity like a cosmic heartbeat. And though the warmth produced is modest compared to the sun's power, it is enough to change everything. It prevents the interior ocean from freezing solid. It drives convection beneath the crust, stirring currents of liquid water. It cracks the ice above, forcing ridges upward and spreading scars across the moon's face. What should have been a silent world becomes restless, sculpted by invisible tides. Beneath kilometers of ice, there may be warmth enough to sustain an ocean liquid for billions of years. And where liquid water endures, so too does the possibility of life. The implications are extraordinary. In defiance of the rules that once seemed absolute, habitability is not confined to the narrow strip around a star. Instead, it emerges wherever energy can flow, wherever liquid water can persist. Europa demonstrates that life might not be bound to sunlit surfaces at all, but might thrive in darkness, nourished by the inner fires of gravity. On Earth, deep in the abyss of the oceans, life exists where sunlight never reaches. Around hydrothermal vents on the seafloor, strange ecosystems flourish in complete darkness, nourished not by photosynthesis but by chemosynthesis. Microbes feeding on minerals and chemical gradients released from the planet's interior. Tube worms, clams, and blind shrimp thrive in alien landscapes of black smoke and boiling water. These are not fragile marginal communities. They are robust, ancient, and self-sufficient. If Earth's life can thrive without sunlight, why not Europa's? If heat and chemistry alone can sustain ecosystems here, could they not do the same beneath an alien sea, locked beneath ice and shielded from the vacuum of space? The paradox deepens. Europa is both hostile and promising. On its surface, radiation from Jupiter bombards the ice, creating a deadly environment where no fragile cell could endure. Yet that very radiation may split water molecules, creating oxidants, powerful chemical energy that could migrate downward into the hidden ocean. Below the surface, the same energy that kills might fuel. Europa thus becomes a world of contradictions, frozen yet warm, hostile yet promising, silent yet restless. A world beyond the sun's embrace that nonetheless whispers the conditions for life. It should not be alive, yet it moves with the rhythm of tides, as if animated by forces older and more enduring than sunlight. This revelation forces a re-evaluation of life's boundaries. No longer can habitability be defined only by distance from a star. Worlds like Europa expand the horizon. They suggest that oceans may lie beneath the crusts of countless icy moons, each with its own hidden potential. Ganymede, Callisto, and Saturn's moon Enceladus all join Europa as candidates in this broader, stranger definition of habitability. Life may not be a fragile flame sheltered only in the warmth of stars, but a persistent force, capable of enduring wherever energy and water coexist. The philosophical weight of this discovery is immense. If Europa's ocean is real, if it stirs with currents and chemistry beneath its icy shield, then life may not be a rare accident confined to Earth. It may be a cosmic inevitability, arising wherever conditions allow. Europa defies expectation. It challenges the notion of silence in the frozen dark. A moon that should be still instead moves with quiet defiance, warmed not by sunlight, but by gravity's relentless pull. Its ocean, if confirmed, would be the most alien sea ever known. A sea without a sky, without seasons, without the light of day. Yet it would also be, in its essence, familiar. Liquid water, the same element that cradled the origins of life on Earth. In this contradiction lies Europa's greatest mystery. It should not be alive, and yet every scar on its surface, every fracture and ridge suggests otherwise. Beneath that fractured crust, there may be motion, chemistry, even life itself. Europa exists as an echo of possibility, a world that refuses to freeze into silence. And when the James Webb Space Telescope turned its eye toward this paradox, it sought not just to observe ice, but to listen for the whispers of an ocean hidden in the shadows of Jupiter's domain. In the dark silence beyond Earth, a machine unfolded like a flower of gold. The James Webb Space Telescope, launched on a December morning in 2021, drifted toward its station 1.5 million kilometers from home. For weeks, it bloomed in space, its mirrors opening with delicate precision, its sunshield unfurling like a great silver sail against the cosmic wind. Every hinge, every wire, every sequence had to succeed without error. And against the odds, it did. Humanity's most ambitious observatory came to life in the cold and emptiness, its golden mirrors aligned, its instruments cooled to near absolute zero, its gaze prepared to pierce the invisible. The telescope was not designed to look where ordinary eyes could see. It was made for the infrared, for wavelengths beyond human vision, where heat and hidden chemistry reveal themselves. For the first time, astronomers held a tool able to read the universe with extraordinary clarity, as if the cosmos had written its secrets in ink visible only to Webb's eyes. Among its first targets was not only the grand sweep of distant galaxies, but also the worlds closer to home. Europa, the icy moon of Jupiter, had long resisted clear answers. It reflected sunlight brilliantly, but what lay on its surface and beneath remained a riddle. Webb's instruments could finally ask the question with unprecedented sensitivity. What is Europa truly made of? And does its surface carry fingerprints of the ocean below? Europa was chosen because it is a paradox wrapped in ice. Its fractured crust, restless geology, and hints of plumes rising into space had raised profound suspicions. To confirm them, scientists needed more than images. They needed chemistry. Webb's spectrometers were built for this purpose, capable of detecting faint patterns of absorption where molecules block specific wavelengths of light. Each element and compound leaves its own subtle signature, like a note in a cosmic symphony. By splitting Europa's reflected light into a spectrum, Webb could read those signatures, decoding them like words in a hidden script. Infrared spectroscopy is a science of shadows. Molecules vibrate, rotate, and stretch in response to light, each motion corresponding to specific wavelengths. When starlight reflects off a surface or passes through a plume of gas, certain bands are absorbed, leaving dark imprints. To ordinary eyes, these are invisible, but to Webb's instruments, they are legible, like letters carved in darkness. To study Europa, Webb became not just a telescope, but a reader of invisible ink. When its gaze fixed on Europa, the data revealed more than ice. There was carbon dioxide frozen into the surface, stark and concentrated in certain regions. This was not the diffuse residue of random chemistry. It clustered in Terra Regio, a region scarred by geologic upheaval. The presence of CO2 in such concentration was startling. On Europa's surface, bathed in Jupiter's harsh radiation, fragile molecules are destroyed within thousands of years. Carbon dioxide should not linger. If it is present, it must be replenished. This raised the haunting possibility that the carbon dioxide did not originate on the surface at all, but from below. If so, the ice was not an impenetrable wall. It was a membrane, fractured and dynamic, allowing the deep ocean to communicate with the frozen crust. Chemicals from the hidden sea may be surfacing, carrying with them hints of conditions beneath. Webb's observations also confirmed the abundance of water ice, as expected, but with subtle variations in its crystalline structure across different terrains. These variations may hint at places where the ice has been disturbed, refrozen, or mixed with salts and organics from within. Though Webb's instruments are not yet precise enough to declare definitively the presence of complex organic molecules, the data do not exclude them. They whisper of possibilities, faint spectral hints of chemistry beyond simple ice. What Webb revealed was not only the presence of carbon dioxide, but its distribution. In Terra Regio, the concentration was unmistakable. Scientists had long suspected that this region was young, perhaps only tens of millions of years old, resurfaced by upheavals from beneath. If that is true, then Webb's detection is a direct fingerprint of exchange between surface and ocean. A pathway, however temporary, between two worlds, the frozen crust above and the abyssal sea below. The implications resonate far beyond Europa. If the ocean communicates with the surface, then its chemistry might be sampled remotely. A plume erupting into space could carry oceanic material directly into the reach of passing spacecraft. The challenge of drilling through kilometers of ice might not be necessary. Instead, the moon itself may do the work, venting its hidden ocean into space for us to read. Yet Webb's discovery also deepens the enigma. If CO2 rises from below, what of other molecules? On Earth, carbon dioxide often accompanies complex organic processes, volcanic activity, biological respiration, or geochemical cycling. Could Europa's ocean mirror such cycles? Could the carbon dioxide detected by Webb be more than inert chemistry? Could it hint at a world where energy and matter are constantly exchanged, where life may find a foothold? Scientists remain cautious. Radiation chemistry on the surface could, in principle, create or rearrange molecules in unexpected ways. Jupiter's magnetosphere bombards Europa relentlessly with charged particles, transforming ice into a chemical laboratory. The CO2 Webb detected may yet be born of surface processes, but its concentrated presence in a geologically young region suggests more than surface radiation alone. It suggests renewal, a dynamic system, a pulse. The telescope's role is not to answer all questions, but to sharpen them. Webb does not resolve the ocean directly, but it narrows the mystery, tightening the circle of what is possible. It reveals where to look, where the clues gather most strongly. Terra Regio becomes not just a scar on the ice, but a message. Here, something stirs beneath. The significance of Webb's findings lies not only in the chemistry itself, but in the method. For the first time, a space telescope designed to study the earliest galaxies has turned its eyes upon a nearby moon and exposed its hidden secrets. Webb bridges scales, from the birth of stars in distant nebulae to the whispers of life's possibility within our solar system. Its mirrors are both a time machine and a microscope, equally capable of probing the first light of the universe and the faint spectral fingerprints of a frozen moon. Europa, once a pale dot in Galileo's lens, is now revealed in molecular detail by an observatory 1,000,000 kilometers from Earth. The arc of discovery stretches across centuries, from the crude telescope of the 17th century to the golden eye of the 21st. And with each step, Europa grows less silent. The discovery of concentrated carbon dioxide does not prove life, but it proves something perhaps just as important: that Europa is active, dynamic, restless. It proves that the ocean and the surface are not strangers, but partners in a hidden dialogue. A dialogue that Webb, with its patient infrared gaze, has begun to overhear. The next question follows naturally. If Webb can detect carbon dioxide on Europa's surface, what else might it find? And if Europa's chemistry can be read from afar, what might be discovered when spacecraft fly closer, when instruments taste the plumes directly, when probes skim the icy crust? For now, Webb has offered a glimpse, a whisper in the dark. Europa is not sealed in silence. Its ocean breathes faintly through cracks in the ice, releasing its secrets into space. And with Webb's golden eye, humanity has seen the first signs of this breath, fragile and fleeting, written in the spectrum of light. The James Webb Space Telescope was designed to look backward in time, to peer across billions of light years and witness the faint red glow of galaxies born when the universe was young. Yet, in turning its golden eye toward a small frozen moon, orbiting Jupiter, it delivered a revelation that shook scientists not with distance, but with intimacy. Europa, long dismissed as a silent world of ice, revealed a chemical whisper that should not exist, yet does. The discovery was carbon dioxide, a simple molecule common across planets and stars, yet strangely out of place here. On Europa's exposed surface, carbon dioxide is a fragile guest. Bathed in relentless radiation from Jupiter's magnetosphere, molecules of CO2 should be torn apart, their bonds severed in the violent chemistry of high-energy particles. In a matter of mere centuries, a blink in geological time, they should vanish, erased by the constant bombardment. And yet Webb detected it. Not diffuse, not scattered across the surface like frost on a window, but concentrated. A reservoir of carbon dioxide gathered in one region. The discovery startled planetary scientists because it implied something more than frozen residue, something dynamic, something replenished. For CO2 to endure, it must have a source. The telescope's infrared spectrometers revealed that this reservoir of carbon dioxide was not ancient, but recent. Its spectral fingerprints were sharp, unmarred by long exposure. It was as if the ice had been freshly marked, as if the moon itself had breathed upward through its frozen crust. The implication was profound. Europa's hidden ocean, sealed beneath tens of kilometers of ice, might not be sealed at all. Instead, it may be restless, fractured, leaking, venting. The carbon dioxide could be carried upward through cracks, plumes, or convective churn, released onto the surface before radiation tears it apart. A cycle of renewal, a planetary pulse. For decades, scientists had speculated that Europa's ocean was locked away, insulated from space, a world apart. If true, it would remain inaccessible, its mysteries trapped beneath an impenetrable ceiling of ice. But Webb's findings hinted otherwise. If carbon dioxide can travel upward, then perhaps salts, minerals, even organic molecules could make the same journey. The ocean would not be silent, but communicative, whispering to the cosmos through fractures in its frozen skin. The shock was not only chemical, it was existential. For centuries, humanity has searched for signs of worlds that could harbor life, places where oceans exist not in myth, but in reality. Yet always, the assumption was distance. Exoplanets orbiting distant stars, unreachable islands of possibility. Europa was different. It was here, circling Jupiter, within the reach of robotic explorers. And now, Webb had revealed that its ocean may not be a tomb, but a voice. Scientists measured the concentration of carbon dioxide against models of radiation destruction. The numbers did not balance. If the CO2 had been deposited long ago, it would not survive. Therefore, something renewed it in the recent past. Perhaps a cryovolcanic plume, a geyser erupting through the ice, spraying oceanic material into space before falling back as frost. Perhaps slow seepage along cracks, where the ice shell flexes under Jupiter's gravity, drawing deep water upward like breath through a reed. Each possibility implied connection. Connection between surface and depth, between the frozen exterior and the hidden ocean below, between silence and life. The shock of Webb's discovery rippled outward, touching not just planetary science, but philosophy. If Europa's ocean can communicate, then so too could life, if it exists there. The boundary between the visible and the hidden grows porous. The moon is no longer a sealed vault, but a living system, engaged in dialogue with space. And yet, the mystery deepens. Why carbon dioxide? On Earth, CO2 is bound to the cycles of respiration and decay. It pours from volcanoes, dissolves in oceans, forms the backbone of life's metabolism. On Europa, its origin remains uncertain. Is it purely geological, the product of carbon-rich minerals altered under pressure? Or is it chemical, forged in interactions between rock and water at the ocean floor? The possibility, however remote, lingers, that CO2 might also arise from processes resembling life. Webb did not answer. It could not. The telescope is a witness, not a judge. Its gold-plated mirrors caught the signal, translated it into spectra, and handed humanity a riddle. What lies beneath remains veiled, waiting for future missions to Europa's surface and sky. Still, the shock endures. Carbon dioxide should not be there. Yet it is. Like a candle flame flickering in a cavern where no fire should burn, its presence challenges expectation. It suggests activity where stillness was assumed, renewal where decay was predicted. And so Europa, once seen as a frozen relic, revealed itself instead as a restless world. A place that resists silence. A place where ice breathes, where oceans whisper, where chemistry defies annihilation. The James Webb Space Telescope, designed to glimpse the birth of galaxies, had instead captured a living heartbeat on a moon 400 million miles from Earth. And in that heartbeat, scientists glimpsed possibility. Not proof, not certainty, but a path forward into mystery. Europa was no longer only a question of ice. It had become a question of exchange, of dialogue, of life's refusal to remain silent in the cold. Beneath Europa's pale and fractured skin, scientists imagine an ocean so vast, so alien, that it stretches the limits of imagination. Models built from decades of observation suggest that under a shell of ice, perhaps 15 to 20 kilometers thick, lies water in liquid form, not in pools or lakes, but in a global sea. Its depth is uncertain, but most estimates place it between 60 and 150 kilometers, a depth that would dwarf Earth's greatest trenches, a volume that could exceed twice the amount of liquid water on our entire planet. This is the paradox. A world so far from the sun, colder than Antarctica's most brutal night, yet hiding more liquid water than Earth itself. A moon that should be silent and frozen, yet may cradle an ocean vast enough to reshape the meaning of habitability. Europa's ocean does not sparkle under sunlight. It lies buried in perpetual night, sealed beneath an ice crust that reflects the light of Jupiter like a frozen mirror. No ray of warmth penetrates its surface. Instead, the ocean's heartbeat comes from below. The immense pull of Jupiter twists Europa's rocky interior, generating heat that rises upward, keeping water liquid in defiance of cosmic cold. Tidal energy, invisible and relentless, powers this alien sea. On Earth, deep oceans conceal hydrothermal vents, fissures in the seafloor where magma meets water, releasing plumes of heat and minerals. Around these vents thrive ecosystems utterly independent of sunlight. Blind shrimp, giant tube worms, strange bacteria, all survive on chemical energy, weaving life from the raw interaction of rock and water. For Europa, scientists suspect a similar process. If its rocky seafloor is fractured and heated, if hydrothermal vents rise into the dark sea, then chemical energy could flow, forming the foundation of ecosystems alien yet familiar. The question is no longer simply whether Europa's ocean exists. That is all but certain. The question is what stirs within it. Could microbial colonies cling to mineral chimneys in the deep? Could chemical gradients sustain networks of metabolism as they do on Earth's abyssal plains? Could a world that has never seen the sun still write the story of life? To imagine this ocean is to step into a place unlike anything humans have ever known. Picture a water world where no color but darkness reigns, where no sky has ever arched above, where the only illumination comes from faint chemical reactions in the abyss. A sea that has never known a dawn, yet has persisted for billions of years. In such a place, life, if it exists, would be shaped not by light, but by pressure and chemistry. It would not see, but sense. It would not breathe air, but exchange molecules dissolved in water. It would live not by sunlight's fire, but by the slow, steady release of minerals from rock. It would be a life of patience, of quiet, of endurance. Scientists compare Europa's hidden ocean to Earth's Antarctic subglacial lakes, such as Lake Vostok, sealed beneath kilometers of ice for millions of years. In these isolated waters, microbes have been found, surviving in darkness, feeding on minerals trapped in the ice. These discoveries prove that life can endure in conditions eerily similar to those imagined for Europa. And yet, Europa's ocean is larger, deeper, older, and perhaps more dynamic. The chemistry of the ocean remains speculation, glimpsed only through indirect hints. The presence of salts on Europa's surface, revealed by telescopes, suggests that the ocean is briny. If salts migrate upward through cracks, then the ocean is not pure but chemically rich, filled with sodium, magnesium, perhaps sulfates. An ocean not barren but flavored with the building blocks of habitability. And then there is the possibility of oxygen. On Europa's surface, radiation from Jupiter tears apart water molecules, releasing oxygen that becomes trapped in the ice. Some models suggest that this oxygen, over time, could migrate downward, seeping into the ocean below. If true, then Europa's ocean might not only contain water and minerals, but oxidants, the chemical breath of life. The scale of this sea is humbling. On Earth, oceans cover 70% of the surface, yet they are shallow compared to the vastness of Europa's depths. Earth's average ocean depth is around 4 kilometers. Europa's may be 20 times deeper. If Earth is a blue marble, Europa is a blue abyss wrapped in ice. Such immensity raises profound questions. In an ocean so large, sealed for billions of years, how many possibilities could unfold? Could life arise independently, following pathways unimagined? Could there be diversity, niches, even ecosystems layered through depth? Or would life, if it exists, remain microbial, constrained by the slow trickle of energy from below? Philosophically, the ocean beneath Europa's ice represents a challenge to human intuition. For so long, life was associated with sunlight, with the warmth of stars. To think that life might thrive in darkness, nourished not by fire but by stone, is to expand the very definition of possibility. It forces humanity to consider that habitability is not rare, but hidden, that the galaxy may be filled not only with planets like Earth, but with oceans sealed beneath ice, waiting in silence. Europa's ocean is a mirror held to our own ignorance. We do not yet know its chemistry. We do not yet know its biology. We do not yet know whether its silence is absolute, or whether it hums with unseen life. Yet already it transforms how we see the universe. A world once thought lifeless may hold more water than Earth. A sea that has never seen sunlight may be alive. For now, the ocean remains sealed, inaccessible, imagined only through models and spectra. Yet every crack on Europa's surface, every hint of venting, every trace of carbon dioxide is a whisper from the depths. The ice is not only a prison, but also a messenger. The ocean beneath the ice is not merely a body of water. It is a question about life, about silence, about the resilience of chemistry in the coldest reaches of space. A question that challenges humanity's assumptions, and in doing so, redefines the possible Europa. The frozen moon of Jupiter conceals an ocean that may be the most promising cradle of life beyond Earth. Not in sunlight, not in warmth, but in darkness. A world that has never known the sun, yet may harbor life that knows only the language of minerals and tides. And so the mystery deepens. Beneath ice that glitters in Jupiter's glow lies a sea older than human history, vaster than Earth's oceans, more silent than any desert. A sea that may hold life, or may hold only solitude. Either answer would reshape the meaning of existence. For decades, Europa was seen as a frozen monument, its beauty lying in stillness, its surface painted in whites and blues, a mirror to Jupiter's storms. Yet as the decades unfolded, signs began to gather, faint at first, then louder, like whispers building toward a chorus. Europa was not still, it was restless. And the evidence came not in a single revelation, but in multiplying signals, each adding weight to a mystery that refused silence. In 2012, the Hubble Space Telescope turned its ultraviolet instruments toward Europa. Against the black canvas of space, it saw something unexpected. Faint, ghostly plumes rising above the moon's limb. They resembled geysers, jets of water vapor erupting from cracks in the ice, soaring more than 100 kilometers into space before dissipating. Their discovery was fragile, tentative, questioned at first. For years, astronomers debated whether the signal was real or an artifact of the data. But if true, it meant Europa's ocean was not sealed. It meant the moon was breathing, exhaling its hidden waters into the cosmos. Years later, Hubble observed similar features again, strengthening the case. The plumes were faint, intermittent, but they echoed the great geysers of Enceladus, Saturn's tiny moon, where Cassini had flown through plumes and tasted their chemistry. Could Europa be performing the same act, though on a larger, more complex stage? Then came Webb, with its unmatched infrared sensitivity. It studied Europa's surface composition, revealing carbon dioxide concentrated in a geologically young region called Terra Regio. This was no coincidence. Terra Regio is chaos terrain, a place where Europa's ice is fractured, churned, and reassembled into strange, jumbled landscapes. Blocks of ice the size of continents appear to have broken apart, drifted and refrozen like shattered glass on an endless sea. It is one of the most dynamic regions on the moon, a scar of movement where the surface speaks of upheaval. The presence of fresh carbon dioxide there, replenished against radiation's erasure, suggests that this region may be a window to the ocean below, a place where material rises, where ice and sea exchange breath, a place where life, if it exists, might leave a trace. With each piece of evidence, the escalation grew. Hubble's plumes, Webb's chemistry, chaos terrain reshaping itself in planetary silence. Taken together, they painted Europa not as static, but as living, a body in motion, an ocean world in flux. The imagery is haunting. Imagine a moon wrapped in silence, yet within it, fractures splitting open, water vapor erupting skyward, falling back as snow. Imagine continents of ice drifting on a hidden ocean, colliding, shattering, refreezing. Imagine the surface as a mosaic of scars, a record of movements invisible yet undeniable. Europa, once thought a frozen marble, reveals itself instead as a restless ocean world. Scientists now believe that Europa's ice shell is not rigid, but dynamic. Tidal forces from Jupiter stretch and compress it, creating fractures that may reach deep into the ice. Chaos terrain is thought to form when the ice crust breaks apart, with blocks tilting, rotating, and floating on slushy or liquid layers beneath. This is no static surface. It is geology in motion, an icy tectonic dance. If plumes exist, as Hubble and Webb suggest, they are a direct consequence of this activity. Water may seep upward along cracks, reaching the surface where pressure drops and vapor bursts into space. It is a violent act, yet also a gift, because plumes carry samples of the ocean into the vacuum. They are natural laboratories, spewing material that spacecraft might one day capture and analyze. The implications ripple outward. If Europa vents material from its ocean, then the ocean communicates with the surface. If the ocean communicates with the surface, then instruments can listen. And if instruments can listen, then one day humanity might hear the echoes of life. The signs multiply not only in data, but in interpretation. Carbon dioxide on the surface means replenishment. Plumes mean exchange. Chaos terrain means mobility. Each signal adds weight to the possibility that Europa is not only habitable in theory, but active in practice. The escalation is not gentle. It is profound. In the early 20th century, Europa was just a moon, one of 4 discovered by Galileo, nothing more than a frozen world orbiting Jupiter. By the late 20th century, Voyager and Galileo revealed its cracked surface, hinting at an ocean below. In the 21st, Hubble and Webb began to uncover chemistry and activity. Each decade peels back another layer of silence, until the possibility of life no longer feels distant, but immediate. Terra Regio, the region where Webb found carbon dioxide, may be the most promising site of all. Its youth suggests recent resurfacing, where material from the interior rises upward. Its chemistry hints at connections to the ocean. Its chaos implies that Europa's shell is not merely ice, but a living lid, shifting and rupturing over time. Scientists call it geologically young, but in planetary terms, that could mean tens of millions of years. Still, on cosmic scales, this is yesterday. It is here, perhaps, that Europa speaks most clearly. Here that the boundary between ocean and space thins. Here that plumes might rise, that carbon dioxide might accumulate, that whispers from the ocean might reach instruments orbiting above. The suspense builds because Europa is no longer only potential. It is evidence stacking upon evidence, each piece more compelling than the last. An ocean twice the volume of Earth's, hydrothermal possibilities at its seafloor, salts and organics on its surface, carbon dioxide freshly laid in Terra Regio, plumes hinting at upward breath, chaos terrain testifying to motion. The signs multiply, and with them, the weight of wonder. If life exists anywhere beyond Earth, this is where the clues converge. Not in the fiery deserts of Mars, not in the clouds of Venus, but here, beneath the frozen surface of a distant moon orbiting Jupiter, a place of darkness, of pressure, of tides, and yet perhaps of life. And so Europa's story escalates, from a frozen marble to a restless ocean world, from silence to whispers, from possibility to probability. Each discovery intensifies the mystery, tightening the tension, until one question remains. When humanity finally listens closely enough, what will it hear? Beneath the frozen armor of Europa lies one of the most haunting questions in all of science. Not only whether life could endure there, but whether it might have begun there, alone, untouched, and utterly alien. The origins of life are mysteries even on Earth itself. No definitive blueprint explains the first spark, the transformation from inert chemistry into the restless self-organization we call biology. Yet Europa, shrouded in darkness and imprisoned beneath ice, forces scientists to confront this riddle on an even grander stage. One possibility whispers of solitude, that life could have risen independently in Europa's abyss, following pathways unknown. If energy gradients and liquid water were sufficient, then chemistry might have stumbled upon the same strange trick it performed on Earth, building structures that replicate, metabolize, and evolve. On this view, Europa is not a barren reflection of Earth's vitality, but a parallel cradle, a second Genesis hidden beneath the stars. But another possibility is older, more cosmic, panspermia, the idea that life is not rooted solely in planets, but migrates across the void on shattered rock and icy debris. Europa has been struck countless times by comets and asteroids, some carrying fragments ejected from Earth or Mars. Microbes, shielded deep within stone, could theoretically survive the freezing drift of space, protected for millions of years. If so, Europa's ocean might not hold a second Genesis at all, but distant cousins of Earth's first life, seeded by catastrophe, carried on celestial winds, and delivered into a waiting sea. Such thoughts find strength in a simple truth. Life on Earth is astonishingly resilient. Extremophils defy limits that once seemed absolute. In hydrothermal vents on the ocean floor, microbes endure temperatures that boil water under normal pressure. In Antarctic subglacial lakes, cut off from the sun for millennia, colonies survive in cold, nutrient-poor isolation. In acidic pools and radioactive caves, life persists, feeding on energy sources that to humans seem hostile, even impossible. These organisms demonstrate that life is not fragile. It adapts, endures, and thrives in the unlikeliest sanctuaries. Europa offers ingredients that mirror these habitats. Its abyssal plains may host hydrothermal vents, where mineral-laden fluids gush from the seafloor, rich with the chemical energy life craves. Its ice shell may recycle nutrients between surface and ocean, stirred by the ceaseless tug of Jupiter's tides. The triad considered essential by biologists, liquid water, energy sources, and chemistry, appears to be present in abundance. Each piece tightens the circle, each fact builds the case. This is not a barren wasteland, but a system that fulfills the known prerequisites of habitability. The debate sharpens around evolution itself. If life did take hold in Europa's deep, what form might it assume after billions of years in eternal night? The conservative answer is microbial, a biosphere dominated by simple organisms, feeding on minerals, clinging to vents, multiplying in quiet obscurity. On Earth, such microbes ruled alone for most of history, for 3 billion years before complexity blossomed. Europa could still be caught in that primordial era, its seas teeming with invisible empires of cells. Yet speculation allows for more. With sufficient time and resources, could evolution carve more intricate shapes from Europa's canvas? In darkness, eyes would be unnecessary. Sensory systems might evolve around vibration, pressure, or magnetism, reading the hidden currents of the sea. If chemical energy is plentiful, larger organisms could emerge, soft-bodied, slow-moving, adapted to silence. They would know nothing of sunlight or air. Their entire universe would be water, mineral, and tide. To us, they would appear alien. To themselves, they would be complete. Some scientists argue that Europa may resemble Antarctica's Lake Vostok, a hidden reservoir sealed beneath 4 kilometers of ice for millions of years. There, microbial life persists, feeding on minerals leached from rock. If such life can endure in isolation on Earth, perhaps a far greater counterpart survives on Europa, magnified by an ocean 100 times deeper and older than Vostok's. But the challenge remains. How does life endure for billions of years without sunlight's constant influx of energy? On Earth, even the deepest biospheres are indirectly tied to the surface, to oxygen and nutrients produced by photosynthesis. On Europa, no such chain exists. Here, energy must flow from chemistry alone. Sulfur and iron compounds, hydrogen from hydrothermal reactions, oxidants delivered from the icy crust. For some, this limitation makes the prospect of complex life unlikely. Microbes, yes. Multicellular forms, doubtful. And yet, Earth continues to surprise. In the deepest ocean trenches, where pressures crush steel and light never penetrates, entire ecosystems flourish around hydrothermal vents. Giant tube worms, crabs, and clams thrive in absolute darkness, sustained entirely by chemosynthetic microbes. This discovery overturned the assumption that sunlight was the only foundation of abundance. It revealed that life can organize itself around other sources of order, other engines of possibility. If Earth's ocean vents can bloom into vast communities, why not Europa's? The philosophical weight of the question is immense. If Europa hosts life, it reshapes humanity's place in the cosmos. 2 origins of biology within one solar system would imply that life is common, an inevitable consequence of physics and chemistry, waiting wherever conditions allow. If instead, life there is seeded from Earth, then life still spreads easily across worlds, traveling as spores of stone. Either path challenges the notion of Earth's uniqueness. Either path multiplies the horizons of possibility, and if no life exists, if Europa is sterile despite its gifts, then the silence speaks just as loudly. It would suggest that habitability does not guarantee habitation, that the spark is rarer, more delicate than all the ingredients combined. A sobering possibility, reminding us how precious Earth's singular bloom of life truly is. In either case, Europa is not just a moon of Jupiter. It is a cosmic mirror, reflecting humanity's deepest questions back into the void. Did biology arise from solitude or from kinship? Is life inevitable or improbable? Does the ocean beneath the ice cradle the unknown, or does it hold only silence? The questions remain unanswered. But in that unknowing lies the greatest wonder of all, that beyond Earth, beneath a frozen shell, an ancient sea waits, and with it, the possibility of a second Genesis. The search for Europa's secrets is not carried out in isolation. It is a story shaped by the instruments of modern science. Eyes and ears designed to pierce ice, to capture light invisible to human senses, and to interpret whispers of magnetism and gravity. Through these tools, a distant world becomes a little less unreachable. Already, a revolution has begun. The James Webb Space Telescope, suspended 1 million miles from Earth, has turned its vast mirror toward Jupiter's moon. With its infrared gaze, Webb can study Europa in ways no instrument before it has managed. It detects faint glows of heat escaping the surface, maps subtle variations in the ice, and measures the chemistry of water vapor when geyser-like plumes are suspected to erupt. Where Hubble first hinted at these fleeting fountains, Webb has provided clarity, confirming that Europa's crust is replenished, that water from within does not always remain sealed, but sometimes bursts outward into space. Each eruption is not only a spectacle of alien geology, it is a potential window into the ocean itself, yet Webb is only the prelude. On Earth, engineers have been preparing for missions with one purpose: to approach Europa directly, to fly again and again through its icy shadow. to collect data not from afar, but from the silence of its orbit. NASA's Europa Clipper stands at the center of this endeavor. Launched in 2024, it will take a long trajectory outward, using planetary flybys to gain the momentum needed to reach Jupiter. When it arrives in 2030, it will not land, but sweep past Europa more than 40 times. Each pass will be closer, more daring, more detailed than the last. Its instruments are a chorus of precision. Radar capable of penetrating ice tens of kilometers deep will reveal the hidden structure of the crust. Spectrometers will read the fingerprints of surface chemistry, searching for salts, organics, and compounds linked to habitability. Magnetometers will measure how Europa's internal magnetic field bends and shifts within Jupiter's powerful magnetosphere, an indirect probe of the ocean's depth and salinity. Together, these devices will weave a tapestry of evidence, slowly transforming speculation into clarity. At the same time, across the Atlantic, another vessel has begun its journey. The European Space Agency's JUICE mission, Jupiter Icy Moons Explorer, was launched in 2023. Its path is longer and its focus broader. JUICE will explore not only Europa, but also Ganymede and Callisto, the other great icy moons of Jupiter. By comparing them, scientists hope to understand why Europa remains geologically restless, while its siblings seem quieter, more ancient, more still. JUICE will orbit Ganymede, the largest moon in the solar system, but its flybys of Europa will complement those of Clipper, each mission adding a different perspective, a different set of instruments, a different layer to the growing portrait of these frozen worlds. The partnership of Clipper and JUICE marks a turning point. For decades, Europa was a mystery glimpsed only by fleeting visits. Voyager in the late 1970s, Galileo in the 1990s. Those missions revealed its fractured shell and hinted at its inner ocean, but left questions unanswered. Now humanity is returning with purpose, with technology designed for precision, with the patience to linger. For the first time, we are preparing to test the idea of a living ocean beneath ice, not with hope alone, but with data. Yet even these spacecraft, with all their sophistication, remain limited. They can orbit, observe, and measure, but they cannot dive. They cannot reach the ocean itself. For that, scientists imagine the next frontier. Concepts for cryobots, machines capable of melting through kilometers of ice, carrying instruments in their wake, exist in the minds of engineers and in the pages of proposals. Such a probe would descend slowly, shielded from freezing, guided by autonomous navigation, leaving behind a tether to transmit data. After years of descent, it would emerge into the abyss, an alien sea, untouched since the moon's birth. There, it might release submersible drones, small explorers designed to drift and swim in the dark, to seek vents, currents, and perhaps the flicker of life for now. These are dreams. The technological challenges are immense. Power sources that can last for years in isolation, communication lines that can stretch through kilometers of shifting ice, sterilization strict enough to avoid contaminating the very world being studied. Yet the vision remains, persistent as the tides. One day, a probe may pierce Europa's shell. One day, the ocean will no longer be only a theory, but a realm directly encountered. What drives such ambition is not only curiosity, but recognition. To stand at the edge of an ocean on another world is to face the profound. Humanity has mapped Earth's seas, walked its continents, traced its rivers, yet here lies a second ocean, larger than all of Earth's combined, hidden and waiting. To explore it is to cross a threshold unlike any before, to extend biology beyond Earth, or to confirm its silence with certainty. Either result would transform our understanding of life and of ourselves. In this way, the instruments of modern science become more than tools. They are extensions of human wonder, lenses through which imagination becomes evidence, through which possibility becomes knowledge. The James Webb Space Telescope, Europa Clipper, JUICE, and the future cryobots yet to come. They are the bridges that connect Earth to Europa, light to shadow, question to answer, and so humanity waits at the shoreline. A shoreline not of water but of knowledge. The waves that break here are made of data, of faint signatures in infrared light, of fluctuations in magnetic fields, of radar echoes returned from beneath ice. Each is a ripple carrying news from another world. Each is a step closer to crossing into the unknown. When the day comes that instruments descend into Europa's abyss, it will not be only a triumph of technology, It will be a moment in which humanity extends its gaze into a second ocean, realizing that the seas of Earth are not singular, but part of a vaster pattern that stretches across planets and moons. To find life there would be to confirm that biology is not an accident, but a thread woven into the cosmos. To find none would remind us of the precious rarity of the life we hold either way. The shoreline waits. The ocean beneath Europa's ice stirs in silence, timeless and unseen. And on Earth, the instruments are readying, poised to listen, to measure, to reveal. We stand, as we have always stood, on the cusp of discovery, watching horizons, building vessels, preparing to cross. The ocean of another world lies ahead. The possibility of life within Europa's hidden ocean stretches far beyond the boundaries of one frozen moon. It presses against the very framework of how humanity defines existence. For centuries, Earth was thought to be singular, the lone sanctuary of biology in a vast, silent void. But if life stirs beneath Europa's crust, then Earth is no longer a miracle. It is a precedent, a pattern, not an exception. Such a discovery would mean that the conditions for life are not fragile threads woven only once, but universal rhythms repeated wherever water, chemistry, and energy converge. The three elements that sustain biology on Earth, liquid solvent, molecular building blocks, and a source of energy, are not rare, they are abundant. Water flows not only here but across the solar system, locked in the poles of Mars, beneath the ice of Enceladus, hidden within the shadows of Mercury, drifting in comets, and detected in clouds circling distant exoplanets. Chemistry, too, is everywhere. Carbon, oxygen, nitrogen, and hydrogen, the alphabet of molecules, are among the most common elements forged in stars. And energy, in the form of tidal heating, radioactive decay, and hydrothermal activity, burns quietly across countless worlds. If Europa contains life, then the universe itself begins to look less like an empty stage and more like an ocean of possibilities. This reframes the rare Earth hypothesis, the idea that our world is unique, delicately balanced, improbably habitable. Perhaps instead, habitability is not a knife's edge, but a wide plateau. Perhaps the universe tends naturally toward biology when given the chance. As Carl Sagan once reflected, the cosmos may be brimming with life, awaiting the eyes and ears capable of noticing. A single microbe beneath Europa's crust would rewrite this equation, proving that Genesis is not singular but plural, that biology is not a quirk, but a law. Yet such a revelation would not diminish Earth's significance. It would deepen it. To discover that life blooms elsewhere would not strip humanity of meaning, but bind it more intimately to the cosmos. No longer isolated, Earth's creatures would become part of a continuum, threads in a larger fabric that stretches across stars. In this light, our uniqueness shifts. Not the fact of life itself, but the form it has taken here, the languages, the cultures, the stories, the consciousness capable of asking these questions. In the presence of other life, humanity does not shrink, it belongs. The philosophical weight of this possibility has long haunted scientific thought. Albert Einstein once described the universe as incomprehensible, yet insisted that its very comprehensibility was itself a mystery. If life is found on Europa, that comprehensibility deepens, a sign that the principles that shaped Earth are written everywhere. Stephen Hawking argued that the emergence of life may be one of the great inevitabilities of physics, a natural consequence of complexity given enough time. And Carl Sagan, gazing outward with wonder, reminded humanity that life is the means by which the universe knows itself. In this vision, Europa becomes not just a moon of Jupiter, but a mirror, reflecting back the possibility that consciousness itself is not confined to one world, but may be a recurring melody in the symphony of the cosmos. The implications stretch beyond science into philosophy, ethics, and identity. If Europa's ocean holds only microbes, they would still represent an independent genesis, a second chapter of biology written on another page. But if evolution has carried life there further, if multicellular organisms drift in the dark waters, then the revelation would be even more profound. We would no longer be the only complex beings in the solar system. We would share the stage, even if only distantly, with creatures that have never seen the sun for religion. Such a discovery would pose questions as deep as those raised when Galileo revealed Earth's orbit around the sun. For philosophy, it would challenge human exceptionalism, reframing our sense of meaning. For science, it would ignite a new era. Astrobiology, not as speculation, but as direct observation. And for ordinary people, it might offer a new kind of humility, reminding us that the dramas of Earth unfold within a universe alive, with possibilities we have only begun to glimpse. There is also the matter of scale. Europa is but one moon around one planet, orbiting one star among hundreds of billions in the Milky Way. If life exists there, then statistically it should exist elsewhere, scattered across countless hidden oceans, within atmospheres of distant worlds, beneath the red light of alien suns. The discovery of a single second genesis would multiply the probabilities outward, until the silence of the universe no longer feels empty, but waiting. It would imply that biology is not fragile, but stubborn, that wherever conditions allow, life finds a way to bloom, even in shadows, even in ice. This possibility compels a re-examination of humanity's role. Are we witnesses of the cosmos standing apart, or participants in its unfolding? If life is a cosmic pattern, then we are not isolated, but kin. The awareness of such kinship may reshape how humanity treats its own planet. Earth, in this vision, is not just home, but part of a larger community of living worlds. The responsibility to preserve it deepens when seen as one example among many, fragile yet connected. There is, of course, another possibility, that Europa is silent, that its ocean, though vast and dynamic, holds no spark of biology. Even this outcome would carry weight. It would not prove life rare beyond Earth, but it would highlight the precarious balance between chemistry and complexity. It would remind us that existence is not guaranteed, that Earth remains precious precisely because it crossed thresholds other worlds may not have. To know this would still be to know more of ourselves, to understand the knife's edge upon which life balances, and the extraordinary chain of accidents that allowed it to arise here. In either case, Europa transforms the human perspective. It forces the species to look outward, to imagine beyond borders and horizons, to accept that the question of life is larger than Earth. The search itself becomes a mirror, reflecting humanity's deepest need to belong to something greater, to find kinship in the cosmos, whether through microbes beneath ice or through the realization of solitude amid stars. The James Webb Space Telescope has already begun to stretch this mirror toward Europa. The Europa Clipper will soon follow, carrying humanity's instruments to the edge of the unknown. Beyond it, perhaps, will come missions more daring still. Cryobots melting through crust, submarines drifting in abyssal dark, explorers designed to seek kinship not in words, but in molecules and movements. Each step is both scientific and philosophical, both empirical and existential. The search for life on Europa is also the search for humanity's place in the cosmos as the 20th century turned. Sagan's voice carried a reminder. We are a way for the cosmos to know itself. If life exists on Europa, then that self-awareness is not alone. Consciousness may not be Earth's singular achievement, but a phenomenon that rises wherever conditions allow, a flame lit in many corners of the dark. And if consciousness has not yet risen there, still the potential remains, waiting in chemical possibility, in the restless tides beneath the ice. Thus, the question of Europa is not only about biology, it is about meaning. To look upon its frozen plains and know there may be an ocean below is to face the possibility that Earth is neither miracle nor accident, but one note in a greater chorus, a chorus humanity is only beginning to hear. And so, as instruments turn, as missions prepare, as theories sharpen, the implications grow larger. The question of Europa is the question of life itself, and whether the answer is affirmation or silence, humanity will be changed by listening. For to listen is to admit the possibility of kinship. To listen is to step out of isolation. To listen is to belong. The universe waits, and Europa whispers. Europa drifts in the velvet dark like a shard of glass, a fragment chipped from Jupiter's endless crown. To the naked eye, it is nothing more than a pale sphere, its skin carved with scars, its surface etched by silence. But beneath that silence may lie one of the greatest revelations in the history of existence. For Europa is not simply a moon. It is a mirror, a frozen testament to humility, a reminder that even in the coldest corners of the cosmos, life may wait, patient as stone. The oceans beneath its ice have endured for billions of years, sealed from the vacuum above, unshaken by storms, shielded from the fury of Jupiter's magnetic embrace. They have persisted through eras when Earth itself was still molten, through epochs when continents shifted like drifting clouds, through every rise and collapse of empires on our fragile world. Europa's waters have outlived human history itself, and within them, perhaps, lie voices we cannot yet hear, songs of chemistry and biology still unknown, lives built upon scaffolds we have not yet imagined. The James Webb Space Telescope peers toward this frozen world with the patience of a philosopher. It does not simply scan for cracks in the ice, or measure the geysers that plume into the void. Its gaze is an act of meditation, asking a deeper question. What is life, and how many faces can it wear? In the faint spectral lines of Europa's exhaled vapors, Webb searches for molecules that whisper of metabolism, of persistence, of resilience in the darkness. Each photon caught in its mirrors is more than data. It is a message across time, a fragment of a hidden story. Europa confronts humanity with a paradox. It is both a world untouched and a world filled with promise. If its ocean is sterile, it teaches us humility, that life is fragile, contingent, a rare spark that may flicker only briefly in cosmic time. If it teems with creatures, however simple, it teaches us hope, that life is not an accident, but a tendency written into the fabric of the universe, a stubborn insistence that wherever liquid water flows, possibility follows. In both answers lies truth. In both lies meaning. Scientists imagine Europa's floor as a landscape no human eye has seen. There, vents may breathe heat from the moon's hidden mantle, releasing minerals and energy into the abyss. Such vents on Earth teem with beings that thrive without sunlight, creatures whose ancestors predate forests and wings. In Europa's eternal night, such organisms could weave ecosystems alien yet familiar, colonies that live not by light, but by fire from the planet's heart. If so, then life has chosen patience, surviving in silence, untouched since the first whisper of its birth. And yet, even if no cells swim there, Europa still stands as an oracle. It tells us that planets and moons may shelter oceans for aeons, that the recipe for habitability is not confined to warmth and air. It reminds us that Earth is not singular, but part of a chorus of worlds whose secrets we are only beginning to hear. In that chorus, silence is as important as sound. To stand before Europa is to stand at the threshold of philosophy itself. What does it mean, after all, to ask whether we are alone? The question is not merely biological, but existential. It is a mirror we hold to ourselves. If life blooms beyond Earth, then humanity is woven into a vaster tapestry than it ever dreamed. If life does not, then our responsibility grows heavier, for we carry the only known story of consciousness through the cosmos. In both answers, Europa speaks not only of science, but of stewardship, of fragility, of the sacredness of existence itself. The search for life on Europa is not only a quest for discovery, it is a meditation on humility. For billions of years, an ocean has waited in stillness. It has known no sunlight, no sound of voices, no instruments piercing its walls of ice. It has endured through the ages with indifference to whether anyone would ever find it. Soon, for the first time, humanity will knock upon its frozen door, sending probes to taste its vapors, to listen for its murmurs. We come not as conquerors, but as guests, hoping to be welcomed, or at least acknowledged, by a world that has slept since the dawn of time. What awaits in those waters is unknowable, perhaps silence, perhaps symphonies of motion, perhaps the simplest of cells breathing in the dark, perhaps nothing at all. But in each possibility lies wonder. For even silence teaches. Silence teaches us that life is not inevitable, that it is something to be cherished on the world we know. A single cell found there would tell us that we are not unique, that the universe itself prefers company to solitude. A thriving ecosystem would tell us that life is not fragile but tenacious, and that the cosmos is richer than we ever imagined. Europa thus shifts the question. It is no longer whether we are alone, it is how many kinds of life the universe dares to hide within its frozen dreams. For in every geyser erupting into the dark, in every molecule shimmering against starlight, lies the possibility that life's story is being written in countless dialects across countless oceans. And so, the narrative draws to a close. We return to the image of Europa, a pale moon, fractured yet whole, circling its giant planet in eternal silence. Beneath its miles of ice, a vast ocean waits, untouched, unspoiled, unbroken for billions of years. It is an ocean that has never felt sunlight, never heard thunder, never seen the fall of rain. It is the oldest silence in the solar system, a silence that may cradle voices too small for us to hear. Soon, we will listen. Soon, we will knock upon the icy door and wait for an answer. Whatever that answer may be, Europa has already taught us something profound. It has shown us that the universe is not empty but filled with questions, questions that shimmer like stars against the black. And as long as oceans hide beneath ice, as long as planets and moons spin through the void, those questions will remain, patient, waiting for us to learn how to ask them. Europa endures in its frozen slumber, and in that endurance it offers both hope and humility. A hope that we are not alone, a humility that reminds us of our place in a universe vast beyond imagination. In the end, Europa is not just a moon, it is a mirror held up to existence itself. And when we finally open that door, we will not just be entering an ocean, we will be stepping into a new chapter of what it means to be alive.